Hi, so today we're going to be talking about finding the volume of solids of revolution when they are rotated around vertical lines, specifically lines that are not the y-axis. So as a short review, whenever we rotate around horizontal lines, which can be denoted as either the x-axis or y equals some number, the bounds must be in the x range and the radius must be in terms of x. Whenever we rotate around vertical lines, which can be denoted as the y-axis or x equals some number, the bounds must be in the y range this time, and the radius must be in terms of y. So if we have this example, y equals the curves y equals the square root of x and x equals 4, and the area between these two curves rotated around the line x equals 5, the first thing we want to do is visualize it through a graph. So this curve is our curve y equals the square root of x, and this line is our line x equals 4, and the area between them is bounded here. And this is the area we are going to rotate around this line, x equals 5. So, since we are rotating around a vertical line, we must rewrite all our curves so that the radius is in terms of y. So we must rewrite this curve. When we rewrite this curve, we get it as x equals y squared. The next thing we do is we need to find our bounds in the y range. When we look at our graph, we realize that one of our bounds must be y equals 0. This is because the graph never falls below the line y equals 0. Our second bound we can find through setting our curves equal to each other, specifically this curve and this curve. When we set them equal to each other, we get y equals 2 and y equals negative 2. However, since the curve never falls below y equals 0, we can cross this out, leaving us with the bounds y equals 2 and y equals 0. The fourth thing we're going to do is find our inner radius and outer radius. Our inner radius is just going to be the distance from 5 minus the line closer to the line we are rotating around, which is the line x equals 4, so 5 minus 4. And our outer radius is going to be 5 minus the curve that is further away, which is x equals y squared. So 5 minus y squared. Using our inner and outer radius, we are going to solve for the area. The area is just going to be pi, the area of the outer radius, the circle of the outer radius, minus the area of the circle of the inner radius. So pi times 5 minus y squared squared minus pi times 1 squared. When we simplify it, we get this. Finally, we plug this in to find our volume. We plug this into our integral, where the bounds are from 2 to 0, and our function is just the area. This is how you write the integral to solve the area of volume of revolutions of the curves y equals square root of x, x equals 4, rotated around the line x equals 5. Thanks for watching.